Consider the following function. Where x is real, find the possible values of r. So we can see that it is given log to the base 10, and we remember that log has a domain, and this value must be greater than 0. So 4x squared minus ix plus r minus 1 should be greater than 0. And notice that it depends on x. X is variable, and with respect to x, you can see its usual quadratic function, and the graph is what concave up, because coefficient is positive. This coefficient in front of x squared is positive, so it's concave up parabola. And to be greater than 0, it means what values? It means what? Y values. So parabola must be somewhere here above x-axis. And with respect to roots, we can see that there must be what? No roots, no x-intercepts. And to get no roots, discriminant of this quadratic should be what? Should be negative. So we consider discriminant. Discriminant is b squared minus 4ac. b it's minus r squared minus 4ac. c is this. Must be less than 0. And it's like another problem. And it becomes what? R squared minus 16r plus 16 should be less than 0. It's another quadratic function. And we need, again, we need roots of this, and using discriminant, it's 16 squared minus 4 c, and we can factor out 16, so it's 16 minus 4, it's 16 times 12, and roots are minus b, 16 minus root of d, and it's what? It's 4, and root of 12, it's 4 times 3, so it's 4 times 2 times root of 3 over 2a over 2, and it's 8 minus 4 root 3, and another root, it's the same but plus here, so 16 plus, so 8 plus 4 root 3, and again it's concave up parabola because this coefficient is positive, and there are two roots, and we need values. Y values should be negative, and they are, y values are negative between two roots, and we need strictly to be negative. So the solution is r should be greater than 8 minus 4 root 3 and less than 8 plus 4 root 3. You may leave like in exact form, or you may calculate and round to 3 significant figures. And that's all for this question.